You can do thermodynamics. Dead weight gauge problem. Pressures up to 35 bar are measured with a dead weight gauge. The piston diameter is 0.30 centimeters. What is the approximate mass in kilograms of the weights required? You are given the maximum pressure of 35 bar and piston diameter of 0.30 centimeters. The goal is to find the approximate mass of weight in kilograms required. First, pressure equals force divided by area. Second, force equals mass times the acceleration of gravity. With force being equal to mass times the acceleration of gravity. This equation can be substituted for force in the pressure equation. Now pressure equals mass times the acceleration of gravity divided by area. Switching sides, mass times the acceleration of gravity divided by area equals pressure. Multiply both sides by area. The two area variables on the left side of the equation cancel each other out. Now, divide both sides of the equation by the acceleration of gravity. The two constants of acceleration of gravity on the left side of the equation cancel each other out. Now mass equals pressure times area divided by the acceleration of gravity. Area equals pi times diameter squared divided by 4. In engineering, circular area is usually given in terms of diameter, because piping is identified by circular diameter. This equation of area can be substituted for area in the mass equation. The derived equation is mass equals pressure divided by the acceleration of gravity times, in parentheses, pi times diameter squared divided by 4. Now you have your needed derived equation. List your given values. You want to find the mass in units of kilograms. You want to get all your values in the same units of kilograms, meters, and seconds to be able to solve this equation. A conversion that you will need for this problem is that pascals equals kilograms divided by meters times seconds squared. First, do dimensional analysis for your pressure value of 35 bar. 100 kilopascals equals 1 bar. 1000 pascals equals 1 kilopascal. As stated earlier, a unit of pascal equals kilogram divided by meter times second squared. Start cancelling out the units. Multiply the top values together, which equals 3.5 million pascals. Since all the bottom values are 1, all the bottom values can be ignored. This equals 3.5 million kilograms divided by meters times seconds squared. Now do dimensional analysis of the diameter starting with the diameter value of 0.30 centimeters. 1 meter equals 100 centimeters. Cancel out the units of centimeters. Multiply 0.30 times 1 meter, which equals 0.30 meters. 0.30 meter divided by 100 equals 0.003 meters. Now you have diameter in the wanted units of meters. You now have pressure, diameter, and the acceleration of gravity in the wanted units of kilograms, meters, and seconds. Insert the value of 0.003 meters into the diameter variable. This value squared equals 0.000009 meters squared. This value times pi divided by 4 equals 0.00007069 meters squared. Now insert the values for pressure and the acceleration of gravity into this equation. The seconds squared units cancel each other out. The value of pressure divided by the acceleration of gravity equals 357,140 kilograms per meters squared. The two units of meters squared cancel each other out. Multiplying the remaining two values together yields a mass of 2.525 kilograms. The mass equals 2.5 kilograms with two significant figures. This is the approximate mass in kilograms of the weights required. Great job! Please subscribe by hitting the subscribe button below the video, or hover over the green subscribe box and then hit the subscribe button. A similar problem with British units is coming up next. Pressures up to 35 atmosphere are measured with a deadweight gauge. The piston diameter is 0.15 inches. What is the approximate mass in pounds mass of the weights required? First, you are given pressure equals 35 atmosphere. Second, you are given the piston diameter is equal to 0.15 inches. Your goal is to find the mass in pounds mass of the weights required. Since this problem is the same as the previous problem but with different values, we can go ahead and use the same equation that we derived earlier. Listing the known pressure, diameter, and the mass that you are trying to solve for. Given the constant of acceleration of gravity is 9.8 meters per second squared. For easier math, convert to metric. You can reconvert back to British units later. Convert to metric units of kilograms, meters, and seconds. First, start with the pressure of 35 atmosphere. Use the conversion of 1 atmosphere equals 101,325 pascals. Cancel the units of atmosphere. Multiplying the top values together equals 3,546,375 pascals. 1 pascal equals 1 kilogram divided by meter second squared. Applying this conversion results in a pressure value of 3,546,375 kilograms per meter second squared. Now you need to convert the diameter of 0.15 inches into metric units. You have the conversion of 1 inch equals 2.54 centimeters. You also have the conversion of 100 centimeters equals 1 meter. Now cancel out the units. Multiplying the top values together equals 0.381 meters. Multiplying the bottom values together equals 100. 0.381 meters divided by 100 equals 0.00381 meters. Now you have the pressure, diameter, and acceleration of gravity in the wanted units, and now you can solve for mass. Now you can solve this equation in the same manner as you solved the equation in the previous problem. Solving this equation yields a mass of 4.126 kilograms. Now you need to convert the kilograms to pound mass. Now you can do the dimensional analysis to convert kilograms to pound mass. Use the conversion of 2.205 pounds mass equals 1 kilogram. Cancel out the units of kilograms. Multiplying the top values together equals 9.098 pounds mass. This answer is 9.1 pounds mass to two significant figures. This is the final answer. Great job! Again, please subscribe by hitting the subscribe button below the video or hover over the green subscribe box in the lower right corner and hit subscribe. Thank you for watching.